Example 3, y to the power 4 subtraction 2xy square plus y to the power 4 dx minus 2x squared y minus 4x y to the power 3 plus sin y dy equals 0. If we compare with this equation, so we can identify m equals x to the power 4 minus 2xy squared plus y to the power 4, and n equals minus 2x squared y subtraction 4x y cube plus sin y. And here you can remove the brackets and you can remove this minus sign, and then according to so next we have to check the exactness. To that we can find da by m over da by y first. So da by n over da by y, if we consider if we differentiate x with respect to y, it means that is a constant, so it becomes 0. Subtraction 2x, that is constant. If you subtract, if you differentiate y, that's come as 2y plus here 4y to the power 3, differentiators of y to the power 4 with respect to y. So you can take this as minus 4xy plus 4y to the power 3, that is da by m over da by y. And we can find da by n over da by x. So here minus 2y, that is constant. If you differentiate x squared with respect to x, that is 2x plus 4y to the power 3 is constant. If derivation of x is 1, then y is a constant with respect to x, then that is 0. So then it is come as minus 4xy plus 4y to the power 3. Therefore da by m over da by y equals da by n over da by x. Thus the equation is exact. The equation is exact. Now we can solve this equation. So how you can solve this equation is, you have to consider first this part. So x to the power 4 minus 2xy squared plus y to the power 4 dx. So you have to derivate this with respect to x, integrate with respect to x. So x to the power 4, so if you derivate this, come as x to the power 5 over 5. No, this one 2x you have to write as it is, y squared, we are differentiating with respect to x. I am writing in here, right? And that is clear for you, right? First integrate x to the power 4 with respect to x. So x to the power 5 over 5 integrating, right? So you know that x to the power 4 you have to add 1 and divide that one. And minus y is a constant. If you derivate x, if you integrate x squared over 2 plus y to the power 4, x is x, so you integrate plus c1, because you know that when you are integrating you have to add a constant, where c1 is an arbitrary constant, right? So we can simplify this. X to the power 5 over 5, you can cancel this 2 and this 2, minus x squared y squared plus xy to the power 4 plus c1. That is first equation, right? Then we can integrate this part separately. So minus 2x squared y minus 4xy cube plus sin y dy. So we have to integrate with respect to y now. Then 2x squared times y to the power 2 over 2, we can integrate this, minus 4x times, here y cube is there, y to the power 4 over 5, plus if you integrate sin y, that is minus cos y, no, minus cos y, minus cos y. Then you can remove this, you can cancel this one, and this come minus x squared y squared here, plus 4 and 4 cancel, xy to the power 4, this is c1, no, c1, and plus cos y plus c2, where c2 is an arbitrary constant. This is second equation. Now you can compare the answers. You got from these two parts. Here x to the power x to the power 5 over 5, it is not included in that one. Minus x squared y squared, yes, both are in there, right? And xy to the power 4, yes. Now by comparing 1 and 2, these two equations, what you can say here, these two are that, but here x to the power 5 x to the power 5 over 5 is there as additional to that equation. And for the c1, what you can say, c1 is equals to this one, no, by comparing this one, c1 equals cos y. And if you compare this one, then which is not in that equal is this one, then c2 is equals x to the power 5 over 5, no, then it is, now then both answers are same. Why? So here then instead of c1 you can write cos y, then it is become that one. Instead of c2 you can write this one, then both are same. Now you can write the answer. What is the answer? You can write 1. This I am writing this one, x to the power 5 over 5 x squared y squared plus xy squared xy to the power 4 xy to the power 4 plus c1. Instead of c1 you can write cos y equals c, where c is an arbitrary constant. You can verify this as earlier we did, and you can take these both again, right? If you differentiate this with respect to x, you can take this answer. If you differentiate this with respect to y, so you can take this answer, right? You may try that, yeah, right? So then you can verify your answer is correct or wrong, right? Okay. Now we will move to the other part, that is separation of variables. If the given equation m dx plus n dy equals 0 can be written as the form f1 of x dx equals f2 of y dy, or capital f1 of x dx plus capital F2 of y dy equals 0, then we call the given equations as one each are the variable are separable. However, the solution of these equations modify the form, and given equations are obtained by the integrating terms of x and y and adding arbitrary constant to any sides. Thus solution those equations are respectively like this way. right? We will try to understand this through an example. So example 1, dx of x equals tan y. Right. Example 1, that is dx over x equals tan y dy. Right, you have to separate the variables, so x terms for one side and y terms for one side, so that is doesn't matter, no, because x and y's are in same, so we can integrate this 1 over x dx equals tan y dy. Right, so tan y we can write, I am writing this way, 1 over x integration of 1 over x dx equals sin y over cos y dy. So integration of cos y is equals derivative differentiation of a cos y equals minus sin y, so I am put two minus signs there, so when I can write then ln x, because you know that integration of 1 over x is ln x equals minus, this is here, right, derivative of cos y is minus sin y, so you can write ln cos y plus c, right, where c is an arbitrary constant. C is an arbitrary constant. So we can write then, further simplify ln x plus ln cos y equals c, right? So additions of log you can write as multiplication x cos y equals c, right? So then you can write x cos y then equals e to the power c, no, this is another constant, so take a equals e to the power c, this is another constant, so it doesn't matter, so this is a value, so you know that c is a number and ec is another number, so I take that number as capital A, right? So then you can write x cos y equals a, right? This is the answer, right? That is not very difficult one. Yes, separation of variables, you did those things in your A levels, and I'm taking another example, right? Example 2, this one. So this is the answer, x cos y equals e to the power c is equal a, right? Consider dy by dx equals 2xy, right? Example 2, dy by dx equals 2xy. So now what you can do is, we have to separate the variable, so x term dx I can take for that side and y I can send for this side, then we can write 1 over y times dy, right? I send y for that side, and 2x times dx, right? 1 over y times dy and 2x times dx, then you can integrate 1 over y times dy equals 2x times dx, right? So you can write ln y equals 2 times x square, integration of x is x squared over 2 plus c. What is c? Where c is an arbitrary constant, right? So ln y equals x squared plus c, then you can write y equals e to the power x squared plus c, then you can write this is addition of ex squared multiplied by ec. What is ec? Ec again constant. I am taking that as a take a equals ec, then y equals a e x to the power 2. This is the answer. That is very easy. That is not very difficult thing. That is how we can solve the equations by using separation of variables. Now we consider homogeneous equations. Homogeneous equations. A homogeneous equations of the first order and first order and degree is one which can be written in the form dy by dx equals fy over x. To test whether the function x and y can be written in the form of right hand side, it is convenient to put y over x equals v or y equals vx. This is the substitution we used to check whether it is homogeneous or not. That is y equals vx. Then after putting this one, it means after substituting this one, then the result of the form should be function of v. So we are taking y equals v, the result should be function of v. That is, if the x all cancel, the test is satisfied. So it means right hand side result, then all the x's should be cancelled. So that is the way of we are checking the homogeneity. Then we can consider an example. So example 1 is dy by dx equals x squared plus y squared over 2x squared. So we can check whether it is homogeneous or not, right? For homogeneous equations, example 1, dy by dx equals x squared plus y squared over 2x squared. As we discussed in the theory, so to check the homogeneity, what we have to do, substitute y equals vx. So dy by dx equals x squared plus, instead of y we are substituting vx squared over 2x squared equals, so then here x squared is common, no? X squared is common here, 1 plus v squared plus 2x squared. So x squared and x squared cancel, then answer is come 1 plus v squared over 2. So according to the theory, what we need to be, so if you substitute y equals vx, the result is the of the form of fv. It means x, there are no x terms should be cancelled, and the final answer should be the function of v. Yes, that is happened. This is function of v. So what can you say? Thus the equation is homogeneous, right? Then you can, if you converted the given equation to that form, if you substitute y equals vx, and the final answer is come as the function of v, it means the given equation is homogeneous, right? There is another example. We consider that one. Dy by dx equals y cube over x squared, right? Example 2.